Oh, I pressed record too soon. Okay. Quiet on the set. This is it now. Oh, am I already recording? Okay. Okay. All right. Hi, everybody. Do we have any homework questions from permutations, arrangements of distinct objects? Number 10. Anything else? Number 12. Okay. Number 13. Okay. So let's take a look at these. Let's look at number 10. Show that the number of, here, I'm going to show you the question. Here's the question. Here's number 10. Show that the number of three-letter words that can be formed from the word campground is the same as the number of permutations of the letters of the word ground. Okay, let's take a look at how this might work. So if we look, here's number 10, campground. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters to work with. Now, how many three-letter words can be made from the words campground? Any ideas how we might do that? 10p3. And if I were to plug that in my calculator, I would get 10 shift NPR3, and I get 720. Good. Now they say, is the same as the number of permutations in ground. So 1, 2, 3, 4, 5, 6. So now we want all the letters. What is 6p6 equal to? 720. Therefore, they are the same. Okay, you were probably thinking it must be this major proof. No, I don't think so. Okay, number 12. Solve for which one in 12 would you like me to do? A or B? A? Okay. So the equation is 7pn3 equals 6pn plus 1 comma 3. So let's sub it into the formula. Now if you recall, the formula is NPR equals n factorial over n minus r factorial. That's the formula we're going to be using. So we're going to sub that into the formulas and try to solve. So we have 7 times n factorial over n minus 3 factorial equals 6 times n plus 1 factorial over n plus 1 minus 3 factorial. Okay, let's see what we can do with this. Well, we're going to have to get rid of factorials. Get rid of factorials. We have to do that in order to be able to solve. So we go, just as before, 7 times n minus 1, n minus 2, n minus 3 factorial, all over n minus 3 factorial is equal to 6 times n, let's see, this is going to be going down to n minus 2, right? This will be over n minus 2 factorial. So it's n times, ignore that minus sign, up, n times, let me just fix that, n minus 1, n minus 2 factorial. So now we can get rid of those factorials. That divides into that divides into that. So right now we have 7 times n minus 1, n minus 2 equals 6 times n times n minus 1. Well, the nice thing is we can divide both sides by n times n minus 1, n times n minus 1. So that divides out and that divides out. So we have 7n minus 14 equals 6. 7n equals 20, n equals 20 over 7. Was that the answer or did I do something wrong? It must be the answer. We can't have 20. It must be wrong. We can't have 20 over 7 factorial. You can't have, sorry? The answer's 20. Okay, let's go. 7 times, did I write the question down wrong? 7 times n factorial. 6n plus. Does the n times n minus 1 not divide out? Oh, I see what I did. I see what I did wrong. Okay, my bad. Let me fix that right now, okay? I made a mistake way at the beginning. If you can't see on the blue, just let me know. But I'm going to make that correction right here. Okay, let me just do it from the beginning. 7 times n minus 1, n minus 2, n minus 3 factorial, all over n minus 3 factorial equals 6 times, I forgot the n plus 1, see? n minus 1 all the way down to n minus 2 factorial, all over n minus 2 factorial. Okay, so that divides out, that divides out, n divides out, right? n minus 1 divides out. Now I think, hopefully this time we'll get the answer of 20. So it's 7n minus 2 equals 6 times n plus 1. Does that look better? 7n minus 14 equals 6n plus 6. N equals 20. Better answer. Yeah, n can be, and you should always check to the original equation just to make sure that your answer works. So you can have 20 factorial, you can have 20 minus 3, which is 17 factorial, you can have 21, you can have, if n is 20, this would be 18, 21 over, yeah, this all makes sense. 21 over 18. So yeah, that works. 20 factorial over 18 factorial. You should always just check, or you can even check up here. P 20, 3 arrangement of 20 things, 3 arrangement of 21 things. Yep, we can have that. So always check, because sometimes you have to eliminate an answer because you can't have a negative factorial type of situation. Okay, so, and there was another question, 13. Is there another one you want me to do in 12? Or are we okay with 12? Why don't we try, which one in 13 would you like me to do? Who asked for 13? Do you want A? Okay, 13A. We have prove. So the difference between proving and solving, prove, is that when we're proving, we have to separate the left side from the right side because we cannot assume they're true unless we've proved it. So you prove it's true before we conclude that it's equal. So Pn and Pnr. Okay, very good. Just making sure I'm trying to minimize any transposition errors. Okay, so Again, we're using that same formula, n factorial over n minus r factorial. And that's the formula we're using. So we have left side equals n factorial over n minus r factorial. Well, that's as far as we can go on the left side. So now we're going to have to go on the right side and see what we can do with that. So now we have right side equals n factorial over n minus r factorial times n minus r factorial all over n minus r minus the whole thing factorial. Yep. Okay. So now we have n factorial over n minus r factorial times n minus r factorial over n minus n is 0, negative r plus r will be 0 factorial. Okay? Minus minus negative r plus r gives us 0 factorial. So I get n factorial. Does anybody see what I did wrong? Let's just check. It should be true. They're not tricking. Oh, I know what I did wrong. This is n minus n factorial, not r. So now we have n factorial over 0 factorial equals n factorial. So now we have left side equals right side. Usually when you get a proving question on a test, it does work. So if it doesn't work, then check your work. Is that good for the homework? Okay. Let's move on to the lesson.